Hi, brief calculus students. We're going to go over the derivatives of logarithmic functions. They're kind of connected with exponential functions, and you'll see that in a minute. So we read it as log base b of x, or if x is a function, we read it as log base b of the function of x. So if we compare the exponential function and the log function, it's pretty cool. You can see that when we get this line y equals x, we can get similar points. Like the exponential function will go through 0, 1. Log function will go through 1, 0. If we take the t point here, we get, surprise, surprise, the point t, log base b of t. That looks right here. But what's really interesting is that if we take the log base b of t and chuck it up to the function b of t, we get the point t. So this is the rule for it. You don't necessarily have to memorize these. It's just kind of fun that b raised to the log base b of t equals t, or the log base b of b raised to the t is t. This one I think is more useful because this is how we find what the exponent is. It's a useful function that way. So how do you take the derivative? It's pretty simple. If you have a constant times a log base b function, then it's the constant times 1 over natural log of b times 1 over the variable or function. So, example, derivative of log base 2 of x is 1 over natural log of 2 times 1 over x. Derivative 4 times natural log of base 3 of x is 4 times natural log of 3 times 1 over x. That 1 over x just keeps coming along. Now, log base 10 is kind of interesting because most people don't write log base 10. They just write log. But it still has to have that natural log of 10 times 1 over x. Of course, there's a special case because natural log is log base e. Take the natural log of e, you get 1. Or in other words, the derivative of the natural log of x equals 1 over x. So again, this is a really popular function for calculus. So, let's say you want to graph the function natural log of x and 1 over x, or some of the previous ones, and you find there's a problem. Your calculator, well, my calculator, maybe your calculator is better, but mine only has log, which is base 10, or natural log, which is base e. So graphing this takes a change of base formula. Basically, if you have log base b of some function, it's either the log of the function divided by the log of the base, or it's the natural log of the function divided by the natural log of the base. You just have to be consistent, whether it's log base 10 or log base e, natural log. So for example, log base 4 of 4096, I could find that by natural log of 4096 divided by natural log of 4. Log base 2 of 8, I could put in log 8 divided by log 2. It has to be consistent, either natural log or log base 10. So to put this in the calculator, as long as you're consistent, both of them will graph to the same thing. So if you're going to hit log for the top, hit log for the bottom. If you're going to hit natural log for the bottom, hit natural log. I'm going to pause and actually go to the calculator. Okay, so natural log of 4096 divided by natural log of 4 equals 6. Remember I told you in that previous formula, coming back here, that it's really useful. Log base b of b to the t is t, helps you find those exponents. So let me come back to this one. So log base 8 divided by log base 2, 3. This is because 2 raised to that third power is 8. This one over here I can graph, so I'll clear this one out. See, I still have the end deriv in there, but if I want log base 2 of x, I could say natural log of x, close parenthesis, divided by natural log of 2, and then it's really better to close the parenthesis in the function. So here's natural log base 2 of x. You notice how it goes through 0, 1. And here is its derivative, right there. Pretty thick. Because it's basically 1 over x, which is this curvy line, times, or divided by the natural log of 2. So let me clear that out. Natural log of 2 is some little small number, but 1 divided by natural log of 2. So it's going to be the 1 over x times about 1.5 more. If I wanted to do that, 4 times log base x divided by log base 3, close parenthesis, just double check which one was that. Yeah, 4 log base 3. Okay, so 4 log, oops, I forgot my division sign. Insert division sign. Okay. So instead of, so it's going up, it's just been pulled up 4 times as strong. And this one is coming down a lot slower than the usual 1 over x function, isn't it? But that's how you can use the calculator to graph these functions. And that's how you can find the nth derivative. Again, if you didn't watch the previous video, that was in the math function. It's called n derivative for numerical derivative. I tell it the variable is the function y1. X is the variable inside the function, and find it for all x. So that's how I found it. If I was out of this and did math and derivative, I have to go variable, y variable, function, y1, variable is x, but find it at 3. If I'm not in the y equals, I have to tell it a specific point. And then that would be the numerical derivative at x equals 3. Okay, so last caution, if you aren't consistent, either log or natural log, you're going to be sunk. Alright, so let's use it with the chain rule. So a times the log of b of a function is a, the constant, times 1 over natural log of b times 1 over the function times the derivative of the function. Now this is where a lot of students have gotten into trouble before because they didn't know when to stop. They said, oh, I still have a function. I need to keep taking the derivative. No. You have your 1 over your function times the derivative of that function, stop. So, for example, derivative of log base 2 of 1 over x is 1 over natural log of 2 times 1 over that x minus 1 times the derivative of that x minus 1. Derivative 4 times log of base 3 of 2x is 4 times 1 over natural log of 3 times 1 over the function times the derivative of the function. If I want to do log x squared, remember log by itself is log base 10. So you have to have this natural log of 10. Or 1 divided by natural log of 10 times 1 over x squared, because that was the function, times the derivative of the function. You stop there, you don't say, oh, what's the derivative of 2x? Okay, sorry, no, stop. I just want to compare here. If you have the natural log of x squared, you don't have to worry about this 1 over anything. Just 1 over x squared times the derivative of that x squared, which is 2x. If you really want to be a smarty pants, you can simplify it even further. But this is a good answer. I can see where it's coming from. And because the log base 2 is a taller function, and then the log base 10, its derivative, on the other hand, is going to be steeper or less steep. So the bigger the function is here, the less steep it is in the derivative. So using for product and quotient rules, let's just do a product rule and call it good. So 3t log hidden base 10 of t squared plus 4t. Oh, I should have said dt. Pause. Okay, there, switched. dt. Okay, so we're going to take the derivative of the first function and then multiply it by the second function. And then add it to the first function times the derivative of the second function. And you notice how right there I changed the log to log base 10 so I could remember what I was doing. So it's just 3 times this function, this log function, plus that 3t times the 1 over natural log times 1 over the function times the derivative of the function. You notice I put a big stop sign here. Don't take any more derivatives. You took the derivative. You are done. So, there you go. A derivative of log functions.